This is example 6.3 on page 222 of your text, and this is an example utilizing Avogadro's law, another one of our simple gas laws. In this law, we are studying the relationship between volume and amount of gas, or moles of gas. So this is another direct relationship in which the number of volume directly correlates the number of moles, directly correlates to the volume of a gas. When one increases, so does the other. When one decreases, the other decreases. So our problem states a male athlete in a kinesiology research study has a lung capacity of 6.15 liters during deep inhalation. At this volume, his lungs contain 0.254 moles of air. During exhalation, his lung volume decreases to 2.55 liters. How many moles of gas does the athlete exhale? And it says to assume constant temperature and pressure. So in this problem, we're going to need to find all of our different variables and figure out what we're solving for. So it says a male athlete has a lung volume of 6.15 liters during deep inhalation. So I'm going to write down V1, N1, V2, N2. So that is going to be our V1 when he's inhaling. And it says at this volume, his lungs contain 0.254 moles of air. That's going to be the mole amount at V1. So that's our N1, 0.254 moles. Then it says during exhalation, his lung volume decreases to 2.55 liters. So that is his V2, 2.55 liters. And then it says how many moles of gas did the athlete exhale. So we're looking for basically the end volume of gas in his lungs after he exhales. So we are given V1, N1, and V2 and solving for N2. So we're going to rearrange our Avogadro's law equation, and the easiest way to do that is to crisscross the variables so that we have V2 times N1 is equal to N2 times V1. And then we can easily divide V1 by both sides to get N2 by itself, wherein N2 is equal to V2 times N1 over V1. Now we can plug our values in. V2 is equal to 2.55 liters. Our N1 is equal to 0.254 atmospheres. And our V1 is equal to 6.15 liters. So in this case, my liters cancel. I'm left in units of atmospheres. And my N2 is going to be 0.105 atmospheres. So that's how much air is present in his lungs after exhalation. But technically, the question is asking us how many moles of gas does the athlete exhale? So in order to find that, we're going to take the starting moles of air in his lungs and subtract out the ending amount of moles in his lungs, and that should give us the amount of moles exhaled. So this problem, we had to find the amount of gas in his lungs after exhaling, but it's technically asking us for the amount of gas exhaled. So we can write a kind of makeshift equation that says moles exhaled is equal to starting moles minus ending moles of gas. So that's going to be our 0.254 moles, our N1, minus what we just solved for, 0.105 mole. And if you subtract those values, the moles exhaled is equal to 0.149 moles. And that is your final answer. So a little bit extra work for this problem to solve for what it was asking us. And I'll go ahead and move this portion up so we can see it a little bit more clearly. So your final answer is moles exhaled 0.149 moles.